All right, so the question is saying that given a matrix A, find A inverse. So for you to find A inverse, A inverse is given by A inverse is given by 1 over determinant of A times the adjoint matrix of A. So it's very easy to find the determinant of this matrix. So the next thing that we should find is the adjoint matrix. Okay, so how do you find the adjoint matrix of this matrix? So the adjoint matrix of A is given by the transpose of the matrix of cofactors of this matrix A. Okay, the transpose given by the transpose of the matrix of cofactors of this matrix A. So how do you find the cofactor, the matrix of cofactors? So we find the cofactor for this element, the cofactor for that element, the cofactor for that element, that element, 2, 6, and negative 3. That is going to give you a matrix of cofactors. So let's find the matrix over the cofactors of this given matrix. So the matrix of cofactors I, J, will be given by, check, this is not a transpose, here we have a transpose here, will be given by, for the first element, okay, the the minor, when you delete this row and then that column, the minor you are going to remain with is this, okay, so you remain with minus 5 and 6, 6 there minus 3, okay, for the first element. For the second element, when you delete this row and that column, you remain with negative 1 and 2 and 6 and negative 3. You remain with negative 1 and 2 and 6 minus 3. Then for the last part here, delete this one and that, remain with minus 1, 2, minus 5 and 6. So you're done with the first row only. Go to the second row, so delete, so find the minor for this matrix here, negative 1. You delete this row and this column, you remain with 3, 6 and negative 2 minus 3. You remain with 3, 6 and minus 2 minus 3. For this element, delete this row and this column, remain with 1, 2, 1, 2 and negative 3, skipping this 6 and negative 2 and negative 3, negative 2 minus 3. And then the last element 6, delete this row where 6 lies and this column where 6 lies, remain with 1, 2 and 3, 6, 1, 2, 3, 6. All right, then for the last one, this one, delete this and that, you have 3 minus 5 minus 2, 6. Then for this one, delete this row where 6 lies and this column where 6 lies, remain with 1, negative 1 and negative 2 and 2, negative 2 and 2. So we have 1 minus 1, negative 2 and 6, supposed to be negative 2 and 6, negative 2 and 6, when you delete this and that. So last element, delete this column and this row, we remain with 1 minus 1, 3 minus 5. Yeah. So now for a matrix of cofactors, the cofactors are simply minors with given signs, either negative or positive. So these are called minors. So for them to become cofactors, you have to assign a sign. You have to give them a sign, either negative or positive. Okay. So the easiest way to give those signs is that for the first minor, just give it a positive. In the second, negative, positive. If this is a positive, this will be negative. This is negative, this will be positive. This is positive, this will be negative. So the signs will be alternating like that. Okay, so this is your matrix over cofactors. What is remaining now is just to evaluate these small determinants. Okay, but what these small determinants. So for the first determinant, you're going to say negative 5 times negative 3, that is 15, minus 6 times 6, 36. Okay, for the second one, you're going to say negative 1 times negative 3. So let me write negative, this negative here, open bracket, negative 1 times negative 3 is positive 3, minus 2 times 6 minus 12, and then for this element here it is negative 1 times 6 negative 6, 2 times negative 10, so negative 10 here, right? Negative 10 there. Okay, be careful of this sign here. Then here we have a negative outside here, then negative 3 times negative 3, we have minus 9, then minus 12, close. Then here we have minus 3, minus 4. And for the last part we have negative, this negative here, 1 times 6, that is 6 minus 6. We are here now 3 times 6. 3 times 6 is 18. 3 times 6 is 18. Then negative 5 times negative 2, positive 10, minus 10, then minus 6, minus 2, then we have minus 5, minus 3. So this is our matrix of cofactors. The rest is just to simplify them now. Just to simplify. So you're simplifying 36 or 12, 15 minus 36, you get negative 21. Negative 3 minus 12, negative 9 times this negative, you get positive 9. Then negative times negative positive, so negative 6 plus 10, you get a 4, positive 4. Then here negative times negative positive, so negative 3 plus 12 is going to give you a 3 times this negative, get a negative 3 there. Okay, again you continue for this one. Negative times negative positive, this should give you a 1, this should give you a 0, this should give you an 8, this should give you a minus 4, and then this should give you a minus 2. Okay, so this is what you have. This is what you have for the matrix over cofactors. Okay, so our adjoint now, what is gonna be our adjoint? The adjoint of A will be the transpose of the matrix of cofactors, transpose. So transpose is simple, it's just writing every row as a column. So this row will be written as a column. So this negative 21, 9, 4 will be written as negative 21, 9, 4. Then this will be written as minus 3, 1, 0. Then this will be written as 8, minus 4, minus 2. So this is the adjoint. So from the formula here for finding the inverse of the 3 by 3 matrix, what is missing is just the determinant. So let's find the determinant for this 3 by 3. Determinant, we're going to have the determinant of A will be given by, okay, let's solve the determinant on the next page. Let's use the next page for the determinant. Okay, so the determinant of A will be given by, you take the first element and get the minor after getting the first element. The first element is 1 outside. The minor for this is this, because we are going to delete this row and this column, so the minor will be 5, 6, 6 minus 3. Then get the second element, so minus the second element is 3. Delete this row and this column, you get minus 1, 2, 6 minus 3. You have that minus 2, minus 1, 2, minus 5, 6, minus 5, 6. Then you simply simplify. Then the first part will be 15 minus 36, because you're multiplying this diagonal to get a 15, and then minus this diagonal to get a 36. Then minus 3, this diagonal is going to give you what? A 3 minus a 12 minus 2. This diagonal is going to give you a 6. Then negative 2 times 2 be positive 10. Okay, positive 10. So now from here you find this is minus 21, minus 3, minus 9, minus 2, and the 4 there. So minus 21 plus the 27, then minus 8. So this is going to give you a minus 2. Okay, minus 2. You found the determinant. So now finally the inverse for this matrix, the inverse, that's the formula for the inverse now. The inverse will be given by inverse of A will be given by 1 over the determinant times the adjoint of A, which is substituting. Now the determinant we found to be negative 2 minus 2, and then the adjoint matrix, we found the adjoint. Well, where is it? That is the adjoint. So we're substituting now by that, which we found is to be minus 21, 9, 4, minus 3, 1, 0, 8 minus 4 minus 2, close. This is the inverse of our given matrix.